Recording.
Recording, okay. So my name is Jared. I am a doctoral student at Auckland University in Computer Science. We have a paper here to present. The title of the paper is A Simulation Study of Impacts of Collaborative Wormhole Attacks in Mobile Ad Hoc Networks. This paper has been authored by me and co-authored by Astrid, Bao, Dr. Fu, and Dr. Zhu. And my colleague George Kossa will present it at the InfoSec conference in Georgia. So let's get moving here. The outline of what we are going to talk about here is, first of all, what are mobile ad hoc networks? And then we'll talk about collaborative wormhole attacks. After that, we'll look at how do they impact, that is, how do collaborative wormhole attacks impact MANET. And then we'll talk about the performance matrices, the throughput and packet overhead, then the simulation parameters, and then our results and conclusions. So what are mobile ad hoc networks? Mobile ad hoc networks basically are networks that do not depend on any physical infrastructure. So nodes in a network can join and leave at any point in time. They are very popular among the military, and they could also be used in emergency responses. And because they don't require any physical infrastructure, it's very easy to deploy. So what are wormhole attacks? Basically, wormhole attacks are kinds of attacks in a network whereby nodes listen to communication and then they tunnel data away from the intended nodes. For example, if we look here, we see that there's a wormhole link between point A and point B. So any traffic, any data that was supposed to pass through these points are being tunneled away. All these red links, they represent wormhole nodes. So as we can see from this picture here, wormhole attacks could cause potential danger to mobile ad hoc networks. For example, networks could even crash, or unintended recipients of messages. Nodes can receive messages that were not intended for them. So it's important that we study the impacts of these nodes in mobile ad hoc networks. So our performance matrices that we're going to use, one is throughput and one is packet overhead. Basically, throughput simply means the amount of data or packets that are going to be transmitted from one link to the other. Packet overhead in this instance simply means the amount of time it takes to transmit packets from one point to the other. So our simulation parameters, when we did our simulation, we did it on NS2, which is open source, and we did it in Ubuntu operating system version 11.4. We used LDV routing protocol, which is ad hoc on-demand vector protocol. In this protocol, the links of the nodes or the routes are used only when necessary. Our simulation time was set at 500. We used CBR. And then when we did our simulation, go ahead. Yeah. When we used our simulation, we had an initial 20 nodes, and then we increased the number of nodes by 10 until we reached 60. And then we did our simulation twice. First, we did the simulation without the wormhole nodes. We measured the throughput, we measured the packet overheads, and then we introduced 4 wormhole nodes in our core, in our simulation. And then again, we measured the throughput, we measured the packet overhead. Our terrain was 750 by 750. So here are our results and some conclusions. When we did our simulation without wormhole nodes, as we can see from the red link, we saw an increase in throughput. We saw that the number of packets being sent was increasing as we increased the number of nodes. When we reran our simulation with wormhole nodes, with 4 wormhole nodes attached to the network, we again recorded our throughput, and we see that the throughput is decreasing when we added the wormhole nodes. The other parameter we used here was packet overhead. And as we said before, this simply means the amount of time it takes to transmit packets from one point to the other. When we ran our simulation without wormhole nodes, we recorded how long it takes when we had 20 nodes through 60 nodes. And then we also recorded how long it took when we added wormhole nodes. So as we can see here, when we added wormhole nodes to our simulation, the packet overhead, the amount of time it takes to transmit packets, increased as opposed to when we did not have wormhole nodes. So, in conclusion, our study shows that both packet overhead and throughput are affected negatively when we have wormhole nodes. So that's the basic thesis of our study, that when you introduce wormhole nodes to mobile ad hoc networks, it affects the throughput, it affects the number of packets that are going to be transmitted. It also does affect the overhead. It makes the time to transmit packets a little bit longer. So this is still open for further studies. And thank you so much for listening to me.